Hello everyone, and here is Manuel from the Bodynodes project. So I will try to do it everything in one take, okay? So this video is about a part of the project, which is the Blender UI. So recently I published a new UI for Blender that is capable of interacting with the Bodynodes sensors that I've made. The Bodynodes sensors are these sensors that you can apply your body and they track your movement. Obviously, when you try to use them, you try to apply the tracking movement somewhere, you will find some problems related to the application that you try to use the data movement. So I tried to put myself in the, in animating characters using Blender, which is this tool that you see here. And yeah, you will see that I found some problems. One of the things was, for example, okay, I get this data and how do I make a character move? What do I mean? Let me show it to you. So first of all, I have to remove some data. And when you take a recording, what you'll get is something like this. Okay. So what is this? This was me, or my movement, taken and applied to a character. Obviously, I'm not moving right now. This is movement that I recorded with my sensors and applied to this character. Cool idea, right? Yeah. Now, spot what is the problem. You see, you can see that it's not moving anywhere. It stays still. And if you think about it, that makes total sense. Obviously, the character doesn't know anything. It just receives movement information of each body part, but it doesn't have the concept of moving in space, because in fact this information is not transmitted by the sensors. So I was there and I was animating and I was like, yeah, now I have to move the character. And I thought to myself, oh, this is gonna be very time consuming. I tried and it was. So I created a function that does it for me. And let me show you how it works. So this is the scripting. I already set it up. So I already selected the player. This is, as you can see, this is red guy. You see? Yeah, this is the head of the red guy. I select the player red guy, and then let's play the animation. It stays still. Let's apply my function, auto work. Oh, it moved. Why is it there now? Give it a look. It's moving along with his feet, or it's moving as it is expected it to move. How did it happen? We will go through this video very shortly. And what you have seen is basically the end result of the algorithm or my so the auto walk function got applied to the character that we have selected and along or in the timeline that we have set, in this case from frame 800 to frame 900. So we set them and then we apply our walking features. So let me show you what is instead the ref walk. The ref walk is a sort of simpler version of auto walk. Auto walk is capable of understanding what is our reference part. Ref walk doesn't know. It basically gets as input the bone that you are selecting and is using that as a reference. So we select, for example, the forearm right, and let's apply it. Let's see what happens. As you can see, the character didn't move at all, almost. It stays in the same position. And why is that? So let's look at the beginning from the center. You can see that it's sort of moving left and right, and the bone stays it stays still. Actually, it stays still in there. And let's see the other part, what is happening. There you go. So as you can see, the body moved, and instead our body part stays practically still. So I want to show you now how did I make this happen. And so we have to dive in some Python code. I hope you are familiar with it, but it's practically very simple. And also we will start from RefWalk. Why? Because it's the easiest or the simpler version of AutoWalk. So RefWalk, it basically applies the function of moving the body, and AutoWalk, it has an additional functionalities of understanding, which is your reference part. So let's dive in. So as you can see, I don't have a really fancy editor. Actually, Notepad++ is more than enough after you have been around for some time. And this is the applied RefWalk functionality. If you want, you can just download the code. It's on GitHub. You will find a link in the description of the video below. And you can have fun in changing it, understanding. So if you have a basic understanding of the code, you'll see that, I'm talking about my project, right? Bodynodes project. But in fact, this code works with any sort of walking animation. So if you have a walking animation and your character is not moving, you can still use this thing. The only thing that you will see is that you have probably to use what are your movers and bones objects. But let's get into it. First of all, in my script, I get collect some data. I'm trying to understand what is the player selected by the user. Where it comes from is basically from here. There you go. When I change this value, the global variable player selected will change, and I will print it, but it's not necessary to print it. Then I try to understand from the frames that I want to work, and I decided to pick it from where you are selected in your animation. So BPI context scene frame start will be 800, and in fact it will read it from here, and frame end will be 900. That's why the script is working along those in that portion of timeline. If you were to put for example 10 here, 100 here, what would happen is that you can select anything you want along this line. In this line, it wouldn't matter because these are set, and at the same time the function will still work. But obviously, you have to wonder about generability, things like that. And then we have to get some information, right? So first of all, I made my, let's call it, so in my scene, basically I have my, how is my scene structured? So we have our let's see, yeah, I can see. So we have, let's not look at the puppet. We have our main character, which is in this case that guy. We applied an armature to it, and an armature is composed of bones, okay? And also we have a mover. There you go. What is the mover? Basically, a mover is an empty object. It doesn't have any area. And what I did is basically create a constraint, bone constraint, from the hip of the, here you can see hip, on the hip of the armature. on the hip bone of the armature to the mover. Why have I done that? Yeah, copy location. So there is a copy location constraint from the mover, from the bone to the mover. And why did I do that? So basically the hip is the main bone of the armature. If I move the hip, okay, if I move the hip, I move all the everything, all the bones. And if the bones move, also the character will move with them. By copying, by setting this constraint, copying the location of the mover, what happens is that now, if I move this empty object around, the bone has to move with it, and as a result, also all the body will move with it. So why have I done that? Why on earth would you actually do this sort of complex, create a new object, create a constraint? Is that because the hip is a bone and it works, or his space, the rotation of its space, the movement of its space is all local. Doesn't have the concept of global movement. Instead, the mover object, since it's created in the world environment, he has the concept of world movement, exactly as the full body. So that what I wanted to do is that if I see a movement, change of movement in the world space, I wanted to translate this movement on the hip. And how do I do that? Well, let's create a word object that will collect all these change of movement, and then let's just anchor a bone to it. And this bone is the hip, which is the main bone of the armature, so that if this object will move, and I will make it move as I want, and you will see how much we will move it, also all the character will move with it. I know it's a sort of weird concept, maybe it could have been simplified, but I wanted to go with it. And so now you understand what are these two variables. These are all the bones. So player selected will be red guy. I get all the pose bones of that object, meaning I will get hip, I will get forearm, I will get, let me show you what I get. I'm getting all of this, all this information as a list, and I will be able to access them by their names. And also I wanted to get the mover object. So this function is a utility function. What does it do? It will return this. So player selected plus the name, which is mover. So if we simplify, what is gonna happen? It's gonna return this. Mover. So that's what the end goal, well, that's what I want. Why did I made it like this? Is to create some generality, so I can select different kind of player and it still works. Why I created a function to do this? It's because I'm using the same concept in different places, and I want to have just one function to just get the body part. And actually, this in this case not really a body part. I want to get an object that works on this line. So I want the player selected. I want to get something, an object related to the player I selected. I can get it very easily with it. So now is the funny part. What I'm doing with all this information. First of all, I want to start from a very fresh position. Not even from the start. I want to start from start -1, which is, so if I set my frame here to be 800, I want to start the algorithm, or I want to set all the position to the position I have at 799, so that everything gets cleared out, I don't have weird positions and things like that. And from that, I will start getting information about what is the reference parts. So the reference parts are, as I said it before, in this function, the reference part, which is in general a foot, comes from the active bond that I selected. So in fact, in there I said, I call it foot, but actually it could be any body part. So I do this, I do that, I do this, I do that. I selected these parts, okay. What is returning here from this call, from this line, it's basically lower leg left, because I selected lower leg left. Or in this case, lower leg right, because I selected lower leg right. So the reference foot, the reference body part I'm selecting will be saved in here. Then, from that, I will get the global location of that part. What is this? Now, first of all, let's not get into the details of what is this function, doesn't matter. But what it does is getting the player I selected and getting the reference body part that I have. It will get the geographic world position of this bone, because this reference body part is a bone. I will get the reference location compared to the world space. Why? Because if I were to get the simple location of the body, of the bone, let's locate here. This is our relative. So if I move it, you can see that it's moving in the world space. Or actually, let's select this one. You can see that it's actually moving, but here is all 0. So in fact, if I were to get the local location, I would see that, oh, it's not moving. But the global location, which is not here, I have to compute it through this function. It is different. Believe me, it's different. I'm not gonna show it. And it depends on the player selected, on the object of the player. So now let's go to the computation. So now let's go to the computational part. What is happening here? First of all, I iterate in all the frame, like in all the frames that I selected from start to end plus 1. Now this is Python. It's not gonna touch end plus 1. It's gonna arrive to end and then it's gonna stop. So range will returns as a set of values from start included to end plus 1, end plus 1 not included. Therefore, it will reach end included. Then what do? I set the frame. Now remember this part. These are actually, do you remember this previous geolocation? This is saved, this is stored. So we got the geographic location, the global location of our reference foot in the previous, at the beginning of the scene. Okay, just keep this in mind. So and it's never changed. Okay, so we want this position will be always the same. So we go to a particular frame, okay, then look at this line. We get a different global location. So this is the reference location our bone was before, and we subtracted to what? Well, guess what it is? Okay, you see, this is exactly the same as this. So I'm getting this thing is basically the position in the global world of the same reference bone at a particular frame. So I set the frame. When I set the frame, all the bone structure gets updated with new locations. I get it and I subtract it to the reference or the previous location or the reference location that it was before. What I get, so this is not a value. It's not just 1, 2, 3. This is a 3-dimensional value. So it's a vector of x, y, z. And you can see that I get this difference vector of location. Then what do I do? And what happens is here is that I just apply, or actually I negate this movement, this translation, this difference of location, of global location on my body part. And instead of applying, I get what is the difference or how my reference bone has moved. I get this, I measure it, and then I basically get the location of my mover. As I explained before, the mover is the object that will move all my body, and I negate it. Like I apply not the same difference, but I apply the negate difference of location to the mover. So if my foot or my body part was going to go forward by 1 unit, or let's say 1 meter. In Blender there is no concept of meter, but let's put it in this way. What I do is I get this difference of meter in the x direction, let's say, and I apply it's 1 plus 1 meter. I negate it, therefore I will put a minus 1 meter to all the body. So what happens if I move my foot forward of 1 meter and my body is going at the same time backwards of 1 meter? What happens is that my body will go backwards of 1 meter, but my foot will stay still in the same position. And therefore, what is happening here, I apply, I negate the difference of location, of global location that my foot or body part is experiencing, and I apply it negated to the mover location, so that it goes, instead of forward, it goes backwards, or it goes in the opposite direction of where my body part is going. Now, this is the concept, right? So why do I have... come on. So why do I have 0 and 1? So as I said, diff g location will be a vector of 3 dimensions, x, y, and z. Guess what? X and y are in position 0 and 1. In here, I'm applying this difference of positioning on the xy plane. I'm not applying movements along the z-axis. Why is that? Because when I was trying to do it, what I noticed is that some weird things were happening. The body part will obviously, or all the full body will start to go up and down, but when you change the, for example, your reference body part, because you want to, for example, the right foot at stopping being my reference point, let's go with the right foot, you will see that, oh, but the right foot is starting from a higher position, and it shouldn't. And you see your body, the more you go animating, you see the body going upwards or downwards on a weird positioning. So by applying only the changes in the x, y, z, you just have your body on the same plane without, you don't see going up and down. And finally, you apply the animation or the location. You insert the keyframe of the mover to that particular frame. And we are only interested in the location. And that's it. That's what that's what ref walk does. Basically gets a bunch of information of movement and then negates the movement that our reference body part is doing and applies to the body, so that the body part or the bone will stay in the same position in the word space. So let's look to what AutoWalk does. So this is the first part, and I will go very fast in this part. I actually invite you to go a little bit into it a little bit more. It's very interesting. I found out a very interesting concept about, you know, what is direction, okay? What is our reference? How do we get that? Here, yeah, you'll see here that we have more or less the same code. In fact, I get reference brave location and then I select it. Now this is much bigger. I'm not gonna go through that too. So let me go as fast as I can. So first of all, I will alternate since it's a walking animation, I will just get as reference part my feet. And my feet are toe R and toe L, or toe left and toe right. What are toe L and toe right? These are toe L and toe right. So these are my reference feet that I'm very interested. So my reference parts with AutoWalk will always be one of the two. How is that decided? So I was like, how do I understand at each point what is my my reference body part? First of all, and I know this video is getting very long, but please stick with me. I have to understand which one is my first bone and in which direction it is going. Okay, this is what this code does. And here, what do I do is understanding. Yeah, there is a bunch of stuff, but the most interesting part is, let me get it, is the walking vector. So what is the walking vector? So I noticed that to understand what is my reference foot and to understand, how these things play, I had to understand which direction was my character going. And how did I did that? It was basically creating a vector of the first ever movement. Okay, so let's go back. So in this case, I see that and I keep checking both of them, both the feet. I keep checking which one is gonna move more or a lot more. And I see, okay, wait, here is moving a lot. As soon as in fact, this movement, global movement, surpass a particular threshold, and I check it. Okay, so I check both of these movements. This is the amplitude of movement, and of left foot and right foot. Okay, if they pass a particular value, I will check which value is bigger, and hopefully I find that just one of them is moving, and then I get it. Okay, so if the left foot is moving a lot, this means that my reference foot is the right foot, is this one, because this one is moving a lot. There must be a reason. It's not that, if I have my right foot, if I am only on my left foot, it will be capable of moving that fast. It's gonna be my reference, okay? So it works in the opposite way, sort of. And as soon as I get this information, I get, all the reference, the global location and stuff like that. And also I'm interested, where is my left foot going? So here in this case, we see that the left foot is moving forwards a lot. You see that? I see, okay, I decided that at this point the right foot is gonna be my reference. What is my walking vector? My walking vector it won't be decided by my right foot. It's gonna be decided by my left foot in this case. Or if this is my reference, the other foot will be, will be setting what is my walking vector. And there you go. That's why we have other deflocation, and then that's what we do this. Now, along this concept, I will be able to understand something very important. Whatever, let's put it this way. Whenever I see my body, my, other foot going forward or along the walking vector, I will know that, okay, my body, so I know that my I'm walking in the same direction. The problem is, let's get it, it's here. You can see that at this point something is happening. The left foot is not going forward anymore, it's going backwards. And at that point, let's go to the code. Okay, this will be negative. This computation of the walking vector of the left foot or the other foot will be, for the first time ever, if I multiply by, my walking vector, the direction I'm going, this will be negative for the first time, because imagine that it's 1, 1, okay? Now, in this frame, it's going back. So values will be negative. You multiply by something that, or a direction that was positive for me, and this generally happens always. There's a negative, it's all negatives in practice all the times. This result will be negative. It means that, okay, we confirm that the other foot is going backwards. At that point, we have to confirm another thing, which is weird, but it's actually very important, is that this part, the reference body part, is behind our other foot. Why is that important? Because there is in fact some part of the animation in which, even though the body part is going backwards, also, and I hope, yeah, you can see it, also this guy is going backwards. And in some cases, it's sort of weird, like there is a confusion. It switches this, then he says that the other foot is going backwards again, but it's still behind. So it will move again forward, then it does it again, right? It will be, oh wait, this is going backwards, so let's go back to the other foot, and it will do the same again here. This would have been the other foot. It will go, oh fuck, oh damn, I'm being wrong. So it's very important to understand which one is behind the other. And as soon as I get that it's behind the other, well, it means that, if it is still behind, yeah, this is becoming at this point my reference point, in fact. And this will be going backwards, and will just so that's how the out-of-walk feature works. It's a lot of more computation, but that's how it does. That's what the concept that you have to take. This is way more complicated. It took me like full day of 2 programmings, but you believe me, that's what it does. It's just a lot of computation to understanding. And just compare it. Okay, let's compare the apply ref walk to the out of walk. The out of walk, it's not that difficult. It's just a for loop and some data. But the out of walk, it's more advanced, because there is some decision making, some history that it has to do. There's a lot of get position. There is some multiplication, vector multiplications to understanding some actually there's vector multiplications. There is some walking vector, and you multiply the vector with the vector that you're going to understand if you're going the same direction or not, and that's it. And yeah, I think after probably 30 minutes or so, I have finished my video, and I hope that I was clear enough. And that was kind of very interesting concepts. This stuff is not on Blender. Why is not? Because no one has ever, this is not how Blender was supposed to be. They just said, okay, Blender, you just want to be able to animate characters. They will be able to figure it out themselves. And you don't really have movement data already. They just made it on the spot, so they could as well move the character along the plane. But in my case, I already have it. I already have movement, man. How do I move the character with just body parts in there? And yeah, that's the big difference. After all of this, I'm really thankful for you to, stick around with me. I really hope that you really like the video and you really like this sort of content, because it's not really only about my project or sensors. There is a lot of maths in there. You can really, if you have a working animation, you can actually take this code and apply to your project. Because as you can see, there is no reference to my body parts. You probably have to modify it, because in your project, you don't really have my same structure. You might find also some better ways to get global location of bones. You might be able to find also a way to get this global location and apply to the local bone without using a mover, as I did. And I use the movement information to do something cool automatically without being there, without having to do that in 1 hour or 2 hours. Because believe me, to do something like that, even this is wrong, because it's moving not how they expected, but to do it in 100 frames, it takes 2 hours. If I were to have to do it by myself manually, this takes 2 hours straight. In our case, we just did it by clicking, so it was 2 seconds. Depends how fast you are in clicking. 1 second maybe, 2 seconds computation, I don't know, but not so much. So that's it. Thank you again. I'm saying a lot. If you really like this kind of content, please leave a like, maybe subscribe, get in touch, comment, do anything. See you next time. Bye.